Okay, the first thing, let's review the physics. Physics review. Now I told you that physics can be broken down into two parts, right? So one is called classical physics. Classical physics. And the other is called modern physics. Okay, so modern physics. Okay, so you can break physics down into two parts: classical physics and modern physics. Now let's start with classical physics first. So whenever we're talking about classical physics, let's draw a timeline here. Let's draw a timeline here. Now classical physics can be said the physics that's from 1700 till the start of 1900. So this is the timeline for classical physics. Now classical physics is made up of mechanics, which is the study of motion. That's what mechanics is all about. And the next part is called electromagnetism. And this is the study of electricity and magnetism. So that's what electromagnetism is all about. Now let's mention the name of the people, the two people who are responsible for that. Mechanics is Newton. He wrote a book called Principles of Mathematics. It's called Principia Mathematica, because it was not written in English, it was written in Latin. Mathematica. So he wrote that book. In that book he laid out all the principles of mechanics. It's one of the most famous science books ever written. Now the other guy we have to know, that guy is James Clerk Maxwell. He wrote many books and he clarified the connection between electricity and magnetism, which is together called electromagnetism. Now these are the 200 years that will comprise of classical physics. Now let's talk about modern physics. Modern physics is made up of similarly two branches. The first is called relativity. Let's call it generally the study of large objects. The study of large objects. What I mean by that is large objects is referred to as stars, galaxies, that sort of things. So these are the large objects. You see, Einstein proved that when we talk about large objects, they don't really work in the classical sense. Classical mechanics, classical electromagnetism does not work here. It doesn't mean they don't work here at all. It just means you have to use new rules for that. So that's relativity, the study of study of large objects. Now the other branch of modern physics is called quantum mechanics. Now, quantum mechanics is logically the study of very small objects. It's a misnomer to call it object, but I'm talking about at the subatomic level. So we are talking about subatomic particles, particles smaller than the atoms. So subatomic particles. So the study of subatomic particles is called quantum mechanics. Now it is also called particle physics. Now let's talk about the person. Of course, everyone knows about the relativity. That's by Albert Einstein. Einstein. Einstein wrote paper in 1905. He wrote 3 or 4 papers. There he wrote first of all a special theory of relativity and a general theory of relativity. He wrote 2 papers. First, the special theory of relativity, and in that paper he talks about the concept of relativity. But Einstein was also partly responsible for the concept of quantum mechanics, because this was also part of his paper in 1905. But quantum mechanics is mostly attributed to Niels Bohr, because later on it was Niels Bohr who was really the advocate of quantum mechanics, and Einstein even said he disagrees many things about quantum mechanics. And there was a debate in Copenhagen where it was a draw. Maybe Einstein lost, but it can be seen as a draw. But Niels Bohr answered to every allegations of Einstein regarding quantum mechanics. So you can say Niels Bohr is more responsible for quantum mechanics than Einstein. So this is what's happened in the nutshell. In a nutshell, so anything after 1900, that's modern physics. Anything between 1900 to 1700, that's called classical physics. You might say anything before 1700, that's pre-classical physics, or some sort of a ancient physics or something like that. Now, one question that can come is, what is actually the study of physics? How is it different from chemistry and biology? Well, first of all, one thing that must be mentioned is that physics, suppose you're throwing a cow. If you're throwing a cow across a field, the biologist will actually look at the cow and the life of the cow, how the cow is breathing, how is it working. That's how the biologists think. The chemist will go a bit deeper and will think about the chemistry inside the cow, the chemicals that make up the digestion of the cow, the bloodstream, what's in the bloodstream. Physics will not look at these 2 intermediate levels. Physics look at the large level, which is the macro level, where the cow is flying. It will think the cow is flying like a ball, a tennis ball. So you will consider the cow just like a tennis ball. So if you look from a farther away, so from a macro viewpoint, so it will look at a macro viewpoint where the cow is considered to be an object, a flying object, just like a tennis ball or anything. How the cow is moving, how is it falling around, where does it land, that's. And at another level, you can say that physics will also look at the micro level, which is the atoms. What are the atoms of the cow? How does the atom interact with each other, the protons and neutrons? So you can see that physics looks either from a large viewpoint or from a small viewpoint, chemistry and biology looks at something else. So when we're talking about biology of the cow, we're talking about the living thing. When we're talking about chemistry, we're going deeper, and when we're talking about physics at the micro level, we're going much more deeper. So that's the overview of physics, and every topic that we have is going to fall under these 4 categories.